Okay, we will start now. Sorry, we are not able to start on time. Got one call from office. So we'll start now the second session of the sixth chapter, which is about setting constraints. So here we want to limit the resource usage by an application. So this is by we're going to set the constraints for the application. So the constraints we are going to set so that so far we have in a project. So we didn't see any constraints. Like we are able to use the pods. We are able to create number of different services. We are able to scale the application to the number we want. But in the production sites, so we are going to see how to limit that, how to set the constraints. So what are the ways you can set the constraints? So this is what we are going to see. So there are two methods to set the constraint, and there are some parameters to set the constraints also. So here we'll study about that. So this section is entirely about setting the constraints. That means restraining the resources. The first thing, who can set the constraints? So in the cluster, the regular project users who is just associated or who is taking care of the project or who is taking care of the development, or they cannot set the constraints. One the cluster level architects, so who have the cluster level permissions to modify the through the cluster, they can modify any resources. So that user, so who is having a cluster level permission, there is full permission at the cluster level, so they can set the constraints. So only they will be setting the constraints, because setting a constraint is the entire cluster scope. So for the entire cluster, you are setting the constraint. So here, so constraints can be set in two different ways. One is we can say constraints, or you can say resource constraints. So the constraints can be set in two different ways. So one is through the something called resource quota. One is called resource quota. Another one is called limit ranges. So through the resource quota and limit ranges, we'll be able to set the constraints. So we'll see the difference between these two. So what is the difference between setting the constraint through the limit range, and what is the difference between setting the constraint using the resource quota? Because more or less you will see we are going to constrain almost the same resources both in the limit ranges and the resource quota, but there is specific difference between using the two. And when it comes to the resource quota, so you can constrain two different types of objects. So one is a normal object, or you can say normal resource. So you can say the objects or normal resources. Another one you're going to constrain is the computational units or computational objects, or computational resource. You can say compute resource. So one is object resource, another one is compute resource. As the name suggests, the compute resource represents the CPU and memory. It represents the CPU, memory, then you can say the storage. So these are some of the computational resources. And other hand, we have here the object resource. The object resource mostly represents the normal objects which we create, like the pods, the services, and the config maps, the secrets, and so forth. So like PVCs. so like that. So you can constrain this kind of resources using, this is all something objects, so which we create. So you can constrain this resources using this object constraint. And when it comes to the CPU, you can constrain the CPU memory like that. So you can set the constraints in multiple ways. So for example, you can set it as a whole CPU, so you can wholly you can control it. Or we have something called when it comes to the computational units, we can define the parameters with some like limits, like the minimum requirement. So when I have to say at least minimum this should be satisfied. So for example, this application want to run with the minimum value, I can set that using something called request. The request will, for example, if I say request, so request.cpu, so that will represent the minimal requirement. So minimum requirement for the application to run on that node. Then there is something like maximum, which is limits. So the limits represents the maximum value. So beyond this value, if you set that value beyond this one, for example, if you set the CPU as limits.cpu, it will be this much, and application load goes beyond that. So in that case, if you don't have the auto scaling enabled, in that case the application may crash. The application may be killed by the OpenShift because it is going beyond that value. In the normal case, if there is no OpenShift, what happens is the application may behave in undesired way. So the application may be getting hanged, or it may be not non-responsive to the client. So here the OpenShift immediately takes an action. If something goes beyond the limits, it will kill that application and it is going to restart that application immediately, so that we don't face a lot of downtime. So that thing will be setting through the limits. So in some cases we'll be using this request and limits. And you can set it as a whole itself. So if you set it as a whole CPU, it will insist like a maximum CPU limit. So for a project, you can set like that. For the application level, you can set like, you can use that request and limits. Later on, we'll see about this when we are learning about the scaling. There will be using these things. So now also we have something limit range. So we'll understand actually the limit range also. We are going to constrain the CPU and memory. So we'll see how the limit range is different from the resource quota. First, we'll understand the object constraint. Then we'll go and understand this CPU constraint or the compute resource constraint used with the differentiating between the resource quota and the limit range. Okay. So now we'll just see how to constrain the object level resources. So at the command line level, you can know about what is the current resource consumption on the node. So using the in the command line level, you can do that. If you use the web console level, so there are a lot of metrics tools. There are a lot of logging tools, logging and metrics tools available to fetch a more concise information, so or precise information through the metrics. So you can have exact information from there. So you can also do a metrics query to analyze the particular parameters or to get the information about the variation in a particular parameter. So you can do that. That will be a sophisticated tool where you can have even the UI. So UI based interfaces to get the data, so the statistical data you can get in a better way. But at a very simple way, in the command line, you can know the current statistics or current usage of the resources using the command called describe command. So you can use OC describe node. So for example, in the node 1, so the master 1, what are the application running on the master 1? From which project that application is running, right? And what is the current usage of that application? So what is the current CPU usage? What is the current memory usage? So all these things you can know from this command. By running this command, you can see here the details about that. So here you can see the at the bottom of this thing, you can see the resource limitations of CPU memory like that. And at the top, you can see the capacity of this node. You can see the allocatable capacity. You can see the actual capacity. You can see that information. And here you can see what is the from which project. So there is some pod is running inside this node. So from which project it is running, and what is this current CPU limits and CPU request and memory. So what is the utilization? So you can see that information. So this will be handy for us to just to get a survey of the cluster. But still more sophisticated way, you can use the logging and metric tools. Later on, we'll see when we are covering the web console, we'll see how to fetch that information. That will give us more clarity or more idea about the current usages and statistics. And that can be very precise also. So up to the pod level, so you can have a very precise. But here, this just gives a simple idea about what is the current usage of that application. So now we'll create a project. So we'll see new project. So let me say this is my demo 8. It's already there, so let me say demo 9. So here, before I create the application, create any application, here I'm going to set the constraint. So here I'm going to set the constraint resource quota for the objects. So like pods and services. So I'm going to set the constraints. So see create quota. So I'm going to say name of the quota. I'm going to say my quota. So here I'm going to constrain the hard limits, like the hardware limits. So I'm going to represent as a hard. Even hard. This is the command line argument. So we have to specify that. So there is no counterpart to this. Actually, sometimes you may think if I set hard, there is something like soft. So nothing like that. So it's just a command line constraint. You have to set like even hard. So here I'm going to constrain. For example, I'm going to say in this project you can use maximum. You can generate maximum number of pods is 5, and maximum number of services you can create is 3. And similarly, you can say the config map for this project you can generate is 10. And similarly, the secrets you can create it 15. So like this, you can keep on adding it. So in the book, you find a table about the different resources. You can constrain the pods, replication controllers, PVCs. So you can constrain this resources. So now I create the resource quota. Now the quota is created. Now I can describe this resource quota. You see describe this quota. This quota, which is my quota. So here you can see things like whatever is set the constraints, the consumption unit. One thing you can note here is all the resources are 0 except the secrets. Secrets are now automatically 9 secrets are consumed, even though we didn't create any secret. That's how we have freshly created the project. We didn't create any secrets, but you can see 9 secret is almost consumed. So the reason for that is because any project you create for the internal project management. So internally to manage that project, the OpenShift creates 9 different secrets. So for managing that project. So these are default secrets will be created. So we don't have anything to do with it, but this is for internal management to manage that project in a secure way. So it is creating some secret over here. So, but what we have to do is we have to give a room for the secret. So when we are setting the secret, now actually I set it 15. So already 9 is consumed, but the user now can only use almost 6. If you want to set the 15 as a desired value for the user, or you want to set that secret for the user to be used 15, then you have to add 9. So you have to set like 24. So then only the 9 will be consumed, and remaining 15 can be used by the user. So only in the case of secret you have to remember this thing, because now already I will see that 9 secrets will be consumed. So we are not creating this. This is for just internal management of the project. OpenShift is creating internally so that it can manage some data securely inside the cluster itself. So for that it is creating some secrets. So other things are 0. So now if I create any application, so we'll see new project, new application, new app. So I'm going to create a new application name. I'm going to save the application called Apache. So I'm going to use -, Docker image. I'm going to get from Quota.io / Red Hat training. Use an image. So I'm deploying an application inside this project. So now one application is deployed. So when you see the resource quota, now you can see one pod is consumed out of 5 and one service is consumed out of 3. So now it is consumed. Now we'll see what happens if I exceed this value. I will get beyond this value. What is going to happen? So if I do OC scale -, replicas, I scale it to like 6 times. So 5 is my limit. I scale it to 6 times. Here use the deployment. Here the deployment name will be Apache. So here already one pod is running. So if I scale it 5 times, see that it is scaled. I will see I scaled it 6 times. Now you can see that 1, 2, 3, 5. Only 5 pods are running. So there is also no clue what happened to the 6th, because I have given here 6 here. Actually 6 should be running. If 6th is not running, I should at least have a clue like 6th is in the pending state or something else should be happening. But here I don't see anything, like only whatever this is allowed by this project. So only that much of thing is running. There is no clue about what happened to the last one. So in that case, if you are seeing that if somebody is scaling, it is trying to scale the application, it is not scaling beyond a certain value. In that case, we have to start the troubleshooting by looking at the status or looking at the events. So there you get the clue. So why it is not deployed. Here, if you look into this, if you look at the status, so use the OC status command. So this will give you a clue here. You can see. So 6 pod is what we requested, and 5. It is now only currently 5 are running. You can see the running. Only 5 are running. So it's trying to grow to the 6th, but something is preventing that from growing to that value. So only the 5 pods are running. So here you get a clue. And also in a different place, like you can see the OC get deployment. So there also you can see the thing. So now you can see the deployment. I'm asking 6, but it's ready only 5. And available currently is 5. So something has happened to the 6th one. So where I can find that information? So the 6th pod. So what happened to that pod? Why it is not deploying? Because I know that it is constrained because of the resource constraint which I have set in the project. But when you are going and doing a general troubleshooting, you should know why it is not deployed. So here we'll see at the events. So we'll just see OC get events. In the events part, you will see why it is not loading. So here this can. So here you should see the warning. So it is failed to create. The error creating the pod. So this is the pod which is supposed to be created. Is failed because forbidden. The reason is exceeded the quota, and it displays you the name of the quota which it's exceeding, and it is going to say requested is 1 is more than, which is 1, which is actually I'm requesting more than the request current available, and already I used 5 and limit is 5. So I cannot create this one pod which is exceeding my limit. So in this way you can see that once I exceed that particular value, so I cannot able to create beyond it. So this is very simple, like we are creating some object, so we are constraining that object, we are setting a quota. So that quota, if you cross beyond that, you cannot able to create it. But normally you will not able to see the quantity which actually that's missing. You will see the current requested which is you are allowed to run, only up to that number you will be able to see. So you have scaled it to maybe scale it 10 times. So what happened to the other 5 pods? You here don't have any clue. At least you should have an error or something, but you don't have any clue. So in that cases, you have to go and check the deployments. Then the deployment should show you the actual number. So if something is missing, so that means something has happened to that. In the status also, in the OC status, OC get events, OC get deployments. There you can find something has happened to the requested number. So from there you can start your troubleshooting. So once you find in the events which quota it's preventing, you can come and check that quota. You can do describe resource quota, mention that name of the quota. There you can come and check what is the current allowed limit. So in case if you want to increase it, you can edit that quota and increase that quota value, so that it's going to allow that particular pod to run. So if the limit it is under that limit. So this is how that resource quota works. And now we come to something called this compute resource. So how do you set a compute resource for a project? So when you set a compute resource, there are two ways. Like we have a project. Okay? So we have a project, and inside the project we are deploying an application. Okay? So using the resource quota, I can say something which I'm setting for the entire project. So this is a project, and this is a sample application which is inside the project. So I need to say the information, like I need to say, for example, I can say the computational unit, I want to constrain something for the entire project. I want to constrain the CPU for the project, so complete project. So the CPU will be shared. So if I constrain this, maybe I have 10 application, maybe 5 application, but the 5 application together in a cumulative way has to work or has to consume the CPU which I'm setting completely through that, completely for a particular project. And there should be a way. Also, I have to say this individual application, the application which is inside this project, can consume this much of CPU, can consume this much of memory. So for individual application, or can say in two ways, like on pod basis, or you can say the container basis. So I can say inside the pod we have a container. On per pod basis, you can say. So one pod can consume this much of things, or one container can consume this much of things. So I want to say that. So using this resource quota, I cannot say that thing. So for saying that one pod can consume this much, and also I can say between some range, between some minimum and maximum value, I want to say that range. So I cannot constrain that on the resource quota. So in that case, I have to go for something called limit range. So limit range, which I'm going to say some quantity for an individual unit. So I can say atomic unit. So atomic unit of the Kubernetes will be pod. So inside the pod we have containers. That is also another atomic unit, but mostly we deal with the pod basis, and sometimes we can deal with the container basis. Per container basis or per pod basis, you can set the values. So for that we have the limit range. So the limit range, what you will be constraining is, you will be constraining the resources on per pod basis, or per container basis, or per image basis. Like that you can do the constraint. So how you can set the constraint? For example, you can take a container. So for a container, you can set the constraint. So I'm giving an example. So the limit range. So here, for example, you have, say this is a container. So this container, you are going to individually say the limit. Like once you create any container, so that container should use minimum CPU. So it should minimum use this much of CPU, and the maximum it should use this much of CPU. Like then you can say the maximum CPU. Then also you can say the default, whether it is going to consume this value or not. It is going to defaultly use it, or because the application wise it is not going to consume some value. So in that case, for some testing purposes, we can go for default values to see that it is actually gaining that value. So whether it is going to utilize that or not, it will just consume that value out of that node. So for this application, it will pre-reserve that node resource. So for some testing purpose, because if I'm not able to do some load testing, so in that case I can set this value and see that that is consuming or not. So once it's consuming, I can be sure that the application is working fine and it's working with respect to that resources. So for testing purpose, you can go for the default value. So normal operation level, so we don't use the default value. For doing some kind of a load testing or doing some kind of adding some pressure to the node, So with respect to the CPU or memory, so we can use this default condition. So default value. Default is something, the value which is it's going to consume, whether it's going to use it or not. And the minimum value is the value which is required for the application to be getting deployed on the worker node. So with the minimum value is not satisfied by the worker node will be avoided by the scheduler. And the maximum value is the value beyond which the application will not be working properly. In case of OpenShift, the maximum values are crossed, the OpenShift will kill that application. So because it cannot able to tolerate the load from the client, so it will kill the application immediately and will restart the application. So that application will be available in a very fast manner, instead of leaving that to the fate of that application itself. Otherwise, the application may hang or maybe will not respond properly. The response may be very slow. In case it is it is exceeding the load of that application. So to avoid that lag or latency, so what the OpenShift is doing, if it is going beyond the maximum value you are setting for that application, it will kill that application. Or if you have enabled the auto scaling factor, it will scale the application, so that it's going to meet the demand or meet the load. That will scale it. If the auto scaling is not enabled, in that case it will kill that application, restart it. So that is available for the client as a fresh one, so that we reduce the downtime or latency in that case. Okay, and we are going to set it. So just for example, for a container, I have set it. So you can set it for you can set the memory, you can set the CPU, you can set the image, all these things you can set it for the through the limit range. So limit range, you are going to say minimum and the maximum value and the default value. And with an example, we'll understand these two things: how a resource quota works in hand with the limit range. So sometimes you may not set a limit range. So you are not interested in per pod basis or per container basis. In that case, you will not go for this. You are interested in just setting for an entire project. Then that case you can limit with the resource quota itself. You don't go and create the limit range. In some case, I want to go hand in with like I set the main project limits. Then I have to set it at the application level, so that the application is going to consume or per container basis or per pod basis. I'm going to set that as constraints. Then I have to go for something called a limit range. So this is at the atomic level. Now always remember this resource quota is a cumulative unit. Like cumulative, when I use the word cumulative, it's going to add upon. It's going to wait till the entire things adds upon, and after that it cannot bear it more than that. Then it is going to restrict that resource. So this is a cumulative, and limit range will be specific. So specific to a container, specific to a pod, specific to a image, specific to a some kind of PVC. So specifically you are mentioning that. So that is what the limit range is. So you are specifying the atomic quantity, so which is in case of the pod or the container. Okay. So we'll understand with an example. So how these two things work together. So how I can set for a project, how I can set a resource quota, and how this resource quota works in hand with the limit ranges. So I will set it for one container basis, and how this is going together is going to work here. So I'm going to use a simple example so that I can understand the concepts clearly. In the book, they have used some like a very complicated file to explain that. So here I just go with a very simple example so that you understand the concept. Then you can, once you understand the concept, you can apply that, and you can build on the complexity. So you can set a complex limit range. Okay. So we'll create another new project. So we'll see new project. So here the project name I'm calling my demo 10. So here I'm going to set a resource constraint. So here I'm going to create a quota. So I'm going to call this as project-quota. So here I'm going to set the hard. So here just I'm going to constrain the CPU. So I'm going to say the CPU is 900 millicores. Then the Kubernetes, you have the cores will be maybe one full core. If I don't find any unit over here, that means it will be a full core. So it represents a full CPU core, vCPU. Or if I mention a YUM, it is a millicore. There's a 1,000th of that core. So like here it will be 0.9 core. So I'm just saying that as a millicore YUM. And I'm going to set this constraint. So just only one constraint I'm setting, so that we can understand that easily. So only one constraint I'm setting is CPU. Now the resource quota is created. Now if you do OC describe resource quota, the name of the resource quota which I said is project quota. So if we can see the project now, nothing is consumed, so it is 0. Now it is the maximum limit is 900 millicores. Now I want to go and specifically say for a container, if I create a container, that container should any container, so irrespective, like if I create a container, irrespective of the application, that container should consume this much. So this much value, this much minimum, this much maximum, this much the default value I have to set it. So here I'm going to set it for a container levels. I'm here to create the container, so I'm going to set that using the limit range. So I want to create the limit range. Unlike the resource quota, for the resource quota you can do it through the command. So you have a direct command to that, and also you can do it as a declarative architecture, like declarative form. So there is 2 options over there. So when there is command, it is easy to use it. But for the limit ranges, I don't have a direct command. So if we don't have a command, as we know that we have to use the declarative format or declarative architecture to say my input to the API server. So here I'm going to declare my input. So I'm going to create a declarative file. The declarative file, I'm going to say my requirement. Okay. So I'll create a file which is limits.yml. You can name this file any name. So naming the file doesn't matter. Only the thing, when you name that file, you point out to the file when you want to call that file for creating that resource. I'm creating a file limits.yml. So here I'm going to say any declarative file, you need to mention 4 different things. One is API version. So V should be caps. So API version, this version which is we are using here V1. Then the kind. So kind here it will be limit range. Or should be caps. Limit range. Then you will mention the metadata. Then the metadata, you are mentioning the name. So when you are creating this resource, in what name that resource should be created. So that name you are mentioning in the metadata. So I want to say this as a project limits. So use the project limits. Then I want to say the specification. So here the actual resource specification starts. You use the spec. So any typical declarative file, you will see these 4 things. So API version, kind and metadata, then the spec. So spec, this whatever the resource is, this spec will be different. So with respect to the particular thing. So here I'm going to set the limits. So here I'm going to say the type. The type. So when you want to set the limits, you can set the limits as I told on per pod basis or per container. In the book they have given the example. So here you have the file which creates that. So you can create it on limit for per pod, or you can create it for per container, or you can create it for image. So per image basis, like that you can do it. So here I'm just going to create for the or container basis. Here I'm going to say the type is for just a container. I'm going to create it for a container basis. So I'm going to constrain the CPU. So always you have to start with the maximum value, then you have to start with the minimum, and third one is default. So default is just for some testing purpose. You can use this default. You can use the default value. Okay. So here whatever the resource you are going to constrain, whether it is a CPU or memory, so you mention that resource here under the max section. You mention that resource. So if you are using the memory, you can mention the memory here. So here I'm just using the CPU. The CPU I'm going to say maximum CPU I'm going to use up to like 250 millicores. This is my maximum CPU. And minimum CPU I want to say the minimum is going to is for the scheduler. So the scheduler will analyze this criteria. so that it is matching, that will choose that node. So this node is not that capability to supply that minimum load, then it will not choose that, that will filter out. So that's a minimum criteria I'm giving. So I'm minimum saying like 10 or 50, I'm going to say 50 millicores. And the default is I'm using it for testing. So whether it is going to utilize this CPU resource or not, it will automatically consume that. So I'm just using it for the testing purpose to see whether it is consuming or not. I'm going to say this is going to consume the 100 millicores. Okay, this is for a general. So like if any container you create, so this is for that particular container, this constraints will be getting applied. Okay, so I'm going to save this file. So here I'm going to create this resource constraint. We'll see create -f, pointer to the file, this name is.yml. Now you can see this resource constraint is created. Now if you do OC describe limit ranges, name of the limit range is project limit. So you can see the limit ranges constraint here. So I'm just setting it for the type is container. So I'm setting it for just one resource, is CPU. This is the minimum, maximum, default values. And now if you look at the project level resource quota, you will see the resource quota, which is the maximum for a project, and I'm limiting it to 900. So for an application, I'm limiting it to some value. So here I'm doing for a project, I'm limiting it to 900. So entire project, I'm limiting to the 9. For one application you are creating, I'm setting some the resource constraint values as like this. So now time to test it. So now I'll deploy an application and test this things, how these two things is going to work together. So I'm going to deploy one new application. So in this project, so my current project is this is my current project. I don't have any application. If I do see get pods, you don't see any application. So if you do see get all, you're not finding any. I think so. I'm going to create a new application. I'm going to say OC new app. So here, just I'm going to simply define one application. I'm going to do a very simple application. I'm going to deploy it. Here I'm going to say just same that a hello app. I'm going to say Docker image. I'm going to deploy it for the on the QA registry, QA.io. So Red Hat training. Then I'm going to say hello -OpenShift. So I'm deploying this image, so deploying this application. So once I deployed it, we'll wait for that application to be running. So now it is running. So once now it is running, you can see the changes. Now if you look at the resource quota now, you can see now it has consumed 100. So because I have created one, because I have defined in the limit range about one container. Now one container is created. So I have created the pod has got one container. One container is created, and that container has consumed this value. So because here the testing value I have given here 100 millicores for any container you are creating, so that should defaultly consume 100 millicores just for testing purpose. You can see now it has started consuming 100 millicores. So because I have created one application inside the project. And if I scale this application, so if I do OC scale and replicate this application, if I scale it, scale the replicas to 3, and the deployment I'm going to say it's hello. So I'm scaling this, replicating this application 3 times. So you should see 3 application will be running. And now you should see the resource utilization will go up to 300 millicores. If you do OC describe resource constraint, you can see that now it has increased to 3. So any container you're creating, it automatically consuming 100 millicores. So now maximum you can create up to 9 applications or 9 containers. So here it's on container basis, so it's not on pod basis. If the, for example, if the pod is having 2 containers inside that pod, so that means I can create almost 3 pods. So 3 pods consumes 4 pods. 4 pods consumes 8 containers. fifth pod, when you're trying to create it, it will exceed that value because fifth pod is going to have 2 containers. So that will exceed that, will become 1000. So that will exceed the value. So you have to calculate on the container basis. You can say the resource constraint even on the pod basis. When you say it's on the pod basis, so when you have multiple containers, whatever you're saying for a pod, that will be shared by the container inside that pod. So if I say for a pod, I can say it is 250 millicores. I'm saying it on the pod basis. Then how many numbers of containers going to be there? So if it is having your 2 containers, the 2 containers share that limit. So maybe one container consume more, another container maybe less, but it will share that entire limit on the pod basis. If it is a container basis, I'm very specific about the container. So I'm not caring about the pod. Pod may have multiple containers. I'm specific to the number of containers inside that application, inside that project. So, and now if I keep on creating it, I can create maximum up to 9 applications. So because one application is consuming 100, so I can create up to 9. So if I go beyond this, if I create 10, so if I, for example, if I scale this application to 10 times, so the 10th application will not be created because that is exceeding the maximum project CPU limit. So now I'm scaling it to 10. So you should see 10 applications, out of 10, 9 applications will be created. You can see now 1, 2, 3, 4, 5 and another 4, so totally 9. So 9 applications will be created. If I look into this now, you see the resource quota. Now the resource quota is completely consumed. So again, we have to look for what happened to the 10th one. So we don't have any clue over here. So we have to go and check the events to get the to know what happened to the 10th one. You can check the status. So this kind of troubleshooting also you will get it. So we see the OC get status. You will see the status. You will see not get, it will be OC status. Just simply OC status. So you see that now currently 9 pods are running. So I have deployed 10, but it's trying to grow into the 10, but 10 is not going because of some issues. Yeah, so here you can see that it's going to 10 and it's not growing, so something is restricting from that. And if you check the events, so you can even check the deployment. So the deployment also you can see you deployed 10, but only 9 are running. So 10th deployment has some issues. So because that has exceeded, that's the reason. So if you do OC get events, the events you can find about that. So here you can see that error. So you can see this here, error creating the pod. So this is the 10th pod supposed to be created. So this is not created. The reason is requested is 10 millicores, so that's 100 millicores of CPU. So it has crossed that value. So the project quota has crossed that project quota value. So that is the reason why it is not able to get deployed. So because maximum limit is reached. So this is how these two things work together. So in a simple way, you can understand the limit range. So you can say I'm specifying it for, I'm specifically specifying for the container, and the compute resource at the resource quota level. So even though we are using the same CPU, here we are constraining the same CPU, but the dimension we are constraining is different. So here we are constraining from the container basis or per pod basis or per image basis. You can do a constraint here. Here it is on entire project basis. It's a cumulative quantity. So it is going to wait till that is going to come up. So this is going to get applied for one resource which you are majorly, which you are mainly creating. So it will commonly get applied to a particular resource. So using that, you can do a constraint. So this depends on how your requirement is, how your use case is going to be there. So some cases we cannot able to use this because this is specific to an application. when it's specific to application, all the applications you create, maybe if it is uniform, it's fine, but if it is a different application, so this may not be suitable to use it. So in that cases, you have to go for some other way to constrain it. Or you can leave this one. You don't want to go for this limit range, just constrain it at the project level itself. So we have to carefully do that, because when you are constraining this kind of things, when you're using this together, all these things, where it is getting limited, where it is getting constrained, where it is getting maybe sometimes it will suffocate the things, or may add pressure to that resource in functioning that. So you should be careful enough to that. So if you're having a project, in that project you have some database kind of an application, so you're deploying 2 or 3 databases. So the nature of the application is same. So you know the database applications maybe consuming this kind of storages, this kind of, then in that case you can go for a uniform deployment, because the nature of the application is the same. But the nature of application differs. So one is database, another is front-end application, another is a business processing application. So the nature of application differs. In that cases, we cannot move for this one. So in that cases, you will constrain the resources in a different way. So you create a different project. So there you'll put the front-end things in the one project. Then you commonly control the constraints for that. And the backend things you'll put in one project, commonly control that here. So we can, using the network policies, we can able to make the communication. So by default, it will communicate without network policies. Defaultly, one project from there can communicate to that project. So that you will constrain the resources in one similar way, in one similar project, so that you're able to preserve the resources. The main idea behind going for the resource constraint is to preserve the resource, so that we are not going to keep on using that. So if I have the project, I'm not going to keep on deploying the applications. So that I'm going to constrain it, so that I save the resources. If you have taken the example of cloud, in the cloud they are going to charge you for how many cores of CPU you are going to use. So the application directly uses a CPU core. So by this way of constraining, you constrain that resource, so that you will boost your economy, or boost your optimize your usage of the resource. So that's the idea behind going for this resource constraint. And now we'll come to the last one. How this resource constraint can be applied in a multiple environment, or you can say for example, I have multiple projects. So how I can apply this for a multiple project in one go? I don't want to do it individually. So how we can apply to the multiple project? And also the next thing, how you can constrain these resources. For example, here we created the project. After creating the project, we create the resource constraint. So I want to create I want to generate a scenario where by the time I create a project, I have the resource constraint in it. So without me going and creating that manually. So automatically, I create a project. Defaultly, that project is going to have some resource constraint. So how to achieve that condition? So we learned about constraints. Now we'll see how to apply this constraint in a broader way. So in a scalable way, how to apply this constraint. So we see that 2 different concepts. One concept is easy, just how to constrain to multiple projects. Another concept is just we have to modify something at the cluster level, so that by the time you create a project, you have the constraints available for you to work around that particular project. So we'll see that 2 concepts. With that, we'll finish up this section. So the first concept is applying quotas to multiple projects. So I have multiple projects. So I have a scenario where I want to apply a uniform constraint. Uniform in a sense, for example, I have 10 projects. For this 10 projects, I'm going to apply a uniform constraint, or the nature of this 10 project is same. So for example, 10 projects is used for testing purpose, or 10 project is for the production purpose, and nature is same. So in that case, I can apply multiple quotas. So instead of going and individually applying the quotas, I can take advantage of this something called cluster quota. So you're going to create a quota. So cluster quota is nothing but you're going to apply the quota in a multiple way. So you're going to set the quota. You're going to say constrain the pods, secret services like that. But you're going to constrain at the cluster level. So how to constrain at the cluster level? This is using the concept of labeling. So you label the project. So let me just open the So you will label the project. So for example, I have 3 projects. So I will label this project with some label. So any label you can do it. So dev or something, some label I'm labeling it. When I'm going to set this quota, by labeling it, I'm grouping these projects together. Okay. So you label it depending on the nature of the project. Then if I use the same label, that means these 3 projects are grouped together. And I'll set a cluster quota. When I'm creating a cluster quota, I'll mention what are the label I mentioned here. I'll point out to this label. Once I point out and create this quota gets applied to all these 3 projects. Okay, whatever the quota we are doing. So whatever the hard resources we are constraining, like pods and services like that. So that will get applied to all these 3 projects together. Okay. So this is what a cluster. Very simple. Like only the command wise the changes. Normally we say OC create quota. Here you have to say cluster quota. Then you have to mention the label, project label. So project label, you have to label the project. So we know how to label the project. We have seen in the network policy how to label a project. Using the OC label command, you label the project. So you will add this option, project label selector, then the name of the label, then after that followed with the constraints. So this will set the constraints for the 3. Now that these 3 projects will have the same constraints. And now the question is, so okay, I have set the cluster quota. So now we have cluster quota and a normal quota, which we are setting at the project level. We can call that as a project quota. So we have a cluster quota, which applies to the multiple projects. We can even individually go and set the project quota. So in a scenario, you get something like I have set some constrained some resource at the cluster quota, as well as I've constrained it using the local project quota. So there is a clash. Like there is, for example, if I constrain the pod is constrained at the cluster quota level, as well as the individually at the project level, they have constraints on that same pod with some quota. So I have a clash. I can have both the things are constrained in the same manner. So this is what we call as we call that as a locking overhead. So locking overhead, this term represents when we constrain the same resource at 2 different levels, one at the cluster quota level and the rest of the project quota level. We are constraining the same resource. We will introduce locking overhead. So locking overhead represents that we will not know the priority. So which will take the priority. So whichever maybe whatever the quota is which is finishing first, that may take the priority, because I'm constraining the same resource at 2 different levels. So we are introducing something like locking overhead, that this will be getting applied. So it's not going to prevent you from applying that, but which will take the precedence, which will get the priority, whether my cluster quota get the priority or my project quota get the priority. We will not know that if you constrain the same resource. If you constrain different resource, that's fine. So one resource you are constraining at the cluster quota, another resource you are constraining at the project level, but that are different constraints. That will be fine. That will not be a problem. A problem comes, you are constraining the same resource. So you are introducing some locking overhead, so will not know the priority. So will be a inconsistent thing on that particular project. So you'll see some kind of troubleshooting issues like this. So there will be a cluster quota as well as the project quota, both constraining the same resource, and which takes precedence will not know. Maybe the project quota finishes first, that will take precedence and that will get applied. Maybe the cluster quota you may have still the quota to be available. So maybe I constrain the pod 10 at the cluster level and the project level constrain it to be 5. The 5 gets finished first. So the quota is finished. It will not enable to create further. Even though if I go and look at the cluster quota level, I can see 10 pods available. After 5, I'm not able to create it. The reason is there is some other constraint is already there. So or else the condition may be reversed. So maybe project quota I have allowed 10, the cluster quota may be allowed 5. So when I'm just looking at the project quota, there is a quota available, but still I'm not able to do it because the cluster level it is preventing it. So we should avoid this locking overhead, so that we are not constraining the resources at the both the levels. So this is one. And other way to set the other way where you can set this constraint using something called modifying the default project template. So whenever we are creating a project, so there is a template. So any resource which you are creating, so for that resource there is a template available at the cluster level. So through that template that resource is actually creating. So we are actually providing the input to the template, like name, description, like that. So if I'm able to modify the template, so core template of that cluster, so through which that resource is created, if I'm able to modify that template, then I can create the quota by the time I create the project. So if I create the project, by the time that quota is also created there, so I did not go and manually do it. So initially I can defaultly set some quotas uniformly using this concept of modifying the project template, or you can default project. We call this as a bootstrap project template. So we'll see how to do that. So next concept is customizing the default project template. So initially, as a user, when you are creating a project, what happens is this bootstrap template is there. So you are giving input to this bootstrap template project, and using this template, actually the project gets created in the API server. So in the cluster, this is a normal behavior. So here, what I will do is I will extract this bootstrap template project, and I will modify the requirement. I will modify this template. Here, what I have to include is I have to include the resource constraint. I have to include the resource quota and limit range in the project template itself. Then after doing that, then I'll create a template out of this one, and I'll place the template in one particular project, and I'll say that information to the general cluster resource. After that, you will be able to when you create a project, you will see that you are able to see the resource constraint you place in the project. After that time, if you are creating any project, you will see that the project automatically gets a resource constraint. So if you want to remove it, you will see the later on how to remove that behavior. So now you can see this using this, I can able to do that. So here you can see the conventional bootstrap project template is there. So you will get this template. You will modify this template, and you will create this template inside this. This is a default project. This is a OpenShift-config. This project will be already available. You will create a template inside this project. So in this way, you will modify. So whatever the resource quota limit ranges you want to modify, you will modify that and will create that resource constraint. And this information you have to say at the cluster level. So cluster level, there is a resource called projects.config OpenShift.io as cluster. There you have to mention the project template name. So initially it will be empty, so it will be using the default one. So initially it will be empty, so here you have to say that project template name. After that, whenever the user is creating a project, it will use this template. It will use this template, and this template already got this resource quota and limit range, and it will be there in that project itself. And it is not going to use the default template, so it's going to use this template, since we are modifying the resource at the cluster level. So this is a process to see that happening. So let's see how this is going to work. So I'll go to the lab. So here I create a sample project. So OC project, I will call this project OC new project. So I'll call this project before. A new project. I'll call this project before. Before means I'm just going to create it, just a name. You can give any name. So before modifying it, I'm going to call this as a project before. Okay, I need to log into cluster. So let me create the project now. Project before. So here, if you see OC get or if you use OC describe resource quota. So if you describe resource quota, you are finding nothing. Similarly, if you describe limit ranges, you are finding nothing here. So this is a general scenario. So now I want to modify this behavior. So by the time I create a project, I should see a resource quota, I should see a limit range. So how to achieve this? This is what our goal is. So for that, we are going to follow these steps. So first I have to modify this conventional bootstrap template, project template. So this template you can find with this command. You can just use OC ADM create bootstrap template project. You can weave this in the YAML format. So this is the template. So actually you are giving the input. So as any project name, the description, all you are giving as input to this template. So through this template only my projects are created. This is a template, and when you execute this command, you are able to get this result. So here get this terminal standard output. If I am able to redirect to the file, then after redirecting to a file, here I'll go and modify my requirement. So in this file, I will add my requirement. After that, I'll create a new template. I have to create it inside this project. This is very important. So I'm creating a template. Template should be created in this OpenShift-config project. This is the default. So whenever you see the OpenShift starting with OpenShift, that means the default projects. You have to create inside this. So the cluster is going to look for, the API server is going to look for the template inside this project. If it is not available inside this project, it's not going to use that template. So always you have to create that inside here. So now I'm going to modify this file. So already I just, to save the time, I will just use the existing one. So here I'm going to use this project template. So here the same template which is over here. The template, the only difference is here I have added the file already has got this resource quota and limit range. So this is what we are adding. So here you can see the API version, kind, metadata. The name it is going, what are the project name you are giving, that will take the quota will take that name, followed by the hyphen quota. And here I'm in the specific section. I'm going to spec section. I'm mentioning the hard limits like CPU and memory. With a sample, like similarly, I'm going to constrain the resource type. Constraint, I'm going to say default request and CPU and memory, and this is much. I'm just adding this line to the default template. So it's already there in the file. So I'm using that solution file. It's already there. In the real time, you have to add this constraint. So what are the constraints you want to add? And I will save this file. So already have this file. Using this file, I'm going to create this resource. But where I have to create it? I have to create it inside this project. So this project is already available. So see get project, you can grep for config, you can find. So this project, one of the project is OpenShift-config. So in this project, I have to create this template. So this is like a thumb rule, like you have to do it like a procedure. So you have to create it. So there is no technical reasons behind it, but you have to, because as a flow reason, so I can say the logical reason, we have to create it inside this. So I'm going to create that here. So OC create -f. So I'm going to point out to the project template, that file. So I have to mention the name of the project now. So the project name is OpenShift-config. So this is a project name. So I have to mention the name of the project. Then I'm creating that resource. Now if you see the template, OC get template. So inside this project, OpenShift-config, you will see that the template is created. You can see that there are 5 blank values. The values represents this one, like the parameters, the project name, display name, like that. So the name of the template is project-request. So this information I have to mention inside the next step. I have to mention this information inside the. I have to update this cluster level resource. The name of the resource is project-config OpenShift.io/cluster. I have to update this resource. So in the resource, what I have to update is I have to say project request template. I have to name what are the name which is you have created it. The name you have to mention inside this one. So initially it will be empty. So if you do OC edit, the resource is project.config project.config.io/cluster. So I'm going to edit this resource. So once I edit it, you're able to see. You can see this is empty. So initially this resource which I'm editing here, the config this project resource which I'm editing. So this is a cluster level. It is initially empty. So I'm going to modify this. So what I'm going to modify is I'm going to mention that template name. So the template name, so you're going to say project request template. So I'll go to the next line. So here I go and modify the name of that. I give the name of the template. So here it is going to be project-request request. That's the name of the template. If you want to know the name, you can go to the next terminal. So here you can just find OC get template. So -n OpenShift -config. So here you can get the name of this project -request. This is a template name which you have created. So I have to mention that name here. Okay. So after mentioning that, now I'm going to save this file. When you're saving the file, so what happens is you have modified something at the core cluster level. So to accept this change, what happens is the APS server redeploys. So APS server, which is already running in this project, pods -n OpenShift APS server, which is running here. So you are making some core change. To accept this new change, what happens is this pod over here will be redeployed. Redeployed in a sense, it will be terminated and new three pods will be created. So we'll see that once I save this file. So once I save this file, you are going to see after some time that these 3 pods will be terminated and 3 new pods will be created, because it is going to accept the change, because I have done something at the cluster level modification. So to accept that change, it is going to redeploy. So the older pod will be terminated and new pod will be running. So you can see now it's started that process. It's terminating it's killing the previous pod and it's creating the new pod. The new pod will have this new information here. After that, so once this is completed, then if you go and create any project, so you're going to see the default whatever they mentioned in that file. You'll see that resource quota and limit range values. So that's the reason I created a project before. So before I do this modification, I created this project. I called this project before. There you find there is no resource here. So if I go and do resource quota, you're not finding any resource quota, you're not finding any limit ranges. Now if I create any project and I execute that command, you will see that resource quota already available. So the resource quota will conform to that whatever you define in that template. So if I just create one new project, so we'll see new project, I'm going to say this is going to be project after. So I can say project after 1. So just giving 1, so that I can create other project. Also other project, if you create any project after now onwards, you'll have that resource quota already there. So if you do now OC describe resource quota, so check that now. Now you see that already I have the resource quota created. It is taking the project name followed by the hyphen quota. You can see whatever you are defined in that file, taking that value. Similarly, you see that limit ranges. So if you use limit ranges, you can see that now limit ranges already there. So just now I created the project. I didn't create any resource quotas. So by default, the resource quota is not. If we create another project, if I create the second project, so I'm creating other project. Project after 2. I'm creating this. Now in this project also you will see the same. So you will see that resource quota already available. You can see that limit ranges. So now any projects you are going to create hereafter, you will have this resource quota. So this will reduce my burden. So instead of going and doing these things, if it is a uniform or it is a common restriction value, then instead of doing that every time, I can do this in a project in this fashion, so that every time the user creates a project, so by defaultly this will be there. So it's not that you cannot create any resource quota. After that, it will be a general constraint. You can create something, and later on you can constrain some other things with respect to a specific project. Maybe you can make it a very general way. Generally, if you create any things, this will be the minimum constraint should be set for the project. In that case, you can use this. And then later on go and do like a fine-tune control. So you can use the project quota, you can use the cluster quota, you can do a fine-tune control, but see that you're not introducing the locking over it. So don't constrain the same resources in multiple places. So here this is constrained, this resource are constrained here, then you're constraining the same resource in the project quota as well as you're constraining the cluster quota. That case you're introducing something called a locking overhead, so we'll not know which will take priority. So that will increase our troubleshooting time, so to detect what is the problem. So since if you don't follow any hierarchical methodology of doing this, you will introduce that logging over it. So see that you're not doing that. And how to revert back to the same previous condition. So here I'm creating the project. Anytime I'm going to create the project, it's going to have but I want to revoke back. So I want to revoke back my things. So to revoke back, it's very simple. No need to delete any template. Just go to this the cluster thing which you have modified. Go here and just remove this statement. Like go here and remove this 2 lines. So this is pointing to that. Remove this 2 line and make it empty again. So as before, make this empty and save the file. Now I changed some resources at the cluster level. Now also you're going to see the redeployment. So something I've changed at the cluster level. You see the redeployment of the API server. So once the API server is redeployed, now you can see the redeployment. So after a redeployment happens, then you can, when you are creating the project again, you will see that you will not have the resource quota by default. It will be back to the previous state. So by default, it will not have any resource constraints. Okay, so with that we complete this session of the second section of the chapter. It's like a very lengthy session. So where we have learned about constraining the resource quota, constraining the resource usage by an application. And we have one more session, is scaling the application. So this is a small session. Can we extend up to 2 o'clock and finish this session also? Or we can continue after lunch?
Yes, we can continue.
Okay.
Sorry, Abdul. Hello.
Okay. So if you have no issues, I will continue and finish this. This is a small session. We're going to see about scaling. To finish it, the 6th chapter will be completed. Okay, now I think now the redeployment is completed. Now if I create any new project now, if I create project 3, if I see now the resource quotas, now we see that the limit ranges are not there by default, and the resource quotas as well is not there. So it has revert back to the condition. The template which you have created will be there, but the references you are removing. So we are achieving this condition. So this is what happening. So whenever the user is creating a project, so it is using this template and it's creating. Now if you remove this reference over here, so ultimately this reference is not here, it's not going to check this, it's going to do the previous one. So previously when we see this, it's going to use the default to bootstrap project template and it's going to create the project. It's not going to follow this one. Only when you modify the cluster resource and say that use this template inside this project, then you're not mentioning the project actually. So just if you mention the name, it is actually going to check inside this project only. So ultimately, if it is not there in this project, if you have created this one elsewhere, so it is not going to look at there. So it's definitely going to look for this project. It's like there's no technical reason, but it's like logically they have created this, so we have to create this inside this project. So then it is going to use that to create that project, and it is going to have that whatever the constraints you have set. Okay, so now we move back to the next concept, which is the scaling. So when it comes to the scaling the application, so it is a horizontal scaling. So whenever you scale an application, it is horizontal in nature. Horizontal in a sense, it is something you're doing at the software level. That's horizontal. If you do something at the hardware level, that will be a vertical scaling. So here we are concerned with the horizontal scaling. So that's our application scaling. So scaling application. So there are 2 ways the scaling can work. One is manual scaling. So whenever I am required that, I'm going to manually scale it. That's a manual scaling. Another is automatic scaling. So automatic scaling, we will set some condition. Depending on that condition, the scaling is going to work. Okay, I'll go here and So I'm not going to emphasize more on manual scaling. So we have seen a lot of time how to do the manual scaling. So we'll use the replica set. Either you go and modify the deployment file, modify the replica value, it automatically scales. Another way is use the command oc scale -- replicas deployment name, then the name of the deployment, then the deployment name. That will automatically scale it. That is a manual scale. So whatever numbers are required, I'm going to require the requested number, I'm scaling it. So to my required number, I'm scaling it. That's a manual scaling. So for the manual scaling, the component which I'm using is the replica set. Okay. And in this case, I'm interested in automatic scaling. So how the application scales itself automatically. So how it is going to scale it, how it is going to horizontally scale itself. So we are going to see that. So if you want to do anything in an automatic way, so at the automatic level, so what you need is you need a condition. You need to have some criteria. Then only you can do the automation. So you will say in the automation that if some condition is met, do these things. If it is not met, continue with the normal things. So like that, you will have a condition. So depending on the condition, the automation is going to take place. So here for doing that automatic scaling, so I need to set a condition. So as of now, only one condition is available for automatic scaling. So that condition is the CPU threshold. So CPU threshold of the application. So if the application CPU threshold goes beyond the value you are setting, goes beyond the target percentage you are setting, then it will scale the application to meet the load, because the application CPU is very crucial. So that decides the loading factor. So that decides the current load the application is handling. So we have only one criteria now as of now. Maybe in the future they may introduce multiple criteria depending on the memory or something like that. So here we just have one criteria now. They are taking the CPU utilization, or can say the target CPU utilization of the application, not the node, the application which is handling the traffic. Once you get beyond that CPU value or CPU target value, the application automatically scales to meet the demand. And there you will say your minimum and maximum. So it is not going to keep on scaling. There you are going to set a constraint also. So between some value, so minimum and maximum value, you are going to set a constraint. Within that value, it is going to scale. Okay, it's not going to keep on scaling it depending on the requirement. Because if I keep on scaling it, so that's not a optimal solution, because that may consume a lot of resources. So even though the benefit which I'm getting it from scaling will not be that much profitable when you compare to the resource consumption in the cluster. So in that case, I have to set a constraint. So automatic scaling, mandatorily you have to set a constraint. Okay, so automatic scaling now, it's based on CPU threshold, and the component which is responsible for the automatic scaling. So because the manual scaling, the component which is responsible for manual scaling is the replica set, and the component which is responsible for automatic scaling is something called horizontal pod autoscaler. So once you set the condition for automatic scaling, this resource will be created. So this component will be created, and this is responsible for automatic scaling. And you will monitor this resource about the current utilization. Okay, so this will do the automatic. So scaling in applications, so we have two means to do it. One is manual scaling. So we did a lot of things in the manual scaling. Now we'll concentrate on automatic scaling. This is the basic theory behind the automatic scaling. So only one condition we can base our automatic scaling. One is the CPU threshold limit of that application, and the component which is responsible for that is horizontal pod autoscaler. Okay, so let me now deploy an application for this automatic scaling. So we need to do some kind of a load testing to test the load which we are using, so that depending on the load, it is going to auto scale itself. So I'm going to do a load testing. Now I can use this. Okay, so here I'll be using some specific image for this. So this image is designed for applying the load test, or to do the load test. So I'm going to use something called load test. So I'm going to use this image, load test image, and this tag as per the latest tag, or you can use the tag version 1.0. So I'm going to use this image for doing the load testing. So that we'll give the load and see the automatic speeding things. So I'll create the new project. Close a new project. So this is going to be my demo 11. I'm creating a new project. I'm going to create a new application. You see new app. I can name. I'm going to save the test app. I'm going to save the Docker image. And use this image. So here just let me just give OC get pods. So here let me use the version 1.0 and deploy the application. Now the application is deployed, so we have to wait the application till it runs. So once the application is running, then I'm going to set the condition. Like I'm going to set the condition for this, and this application now initially it will not have any CPU constraints. It's not requesting any CPU constraints. First I have to set that constraint. So after setting that constraints, then only we can do a load test. So if I move beyond that value, so we'll see how that is when you get beyond that value, how it is going to do the automatic scaling. So you have to set that constraint, because if you look into the application now, if you do OC describe deployment, the name of the deployment which is here, test app, if you look into the deployment here, so this application is not having any constraint. If you look at the containers, this container is not imposing any constraints. It's not consuming any load now. So I'm going to set a constraint for this. The constraint is I'm going to set the minimum CPU and the maximum CPU. I'm going to set this constraint to the application. So I'm going to do OC set resource. So I'm going to say hyphen request. So request is always the minimum which you are specifying. So I'm going to say the CPU, minimum CPU which it will consume is I'm going to save minimum request 10 millicores. And a hyphen I'm going to say the maximum limits. So maximum limits which that's going to consume is I'm going to say 100 millicores. Then I got to mention the deployment. Then I have to mention the deployment name, which here it is test app. Now I have set here I have to mention CPU. I have to mention here CPU. Now the requirement is updated. Now if you look into this application deployment now, you can see that this container we have set the limits. We have set the minimum. The minimum is required for the application to be get deployed on the worker node, and this is the maximum. Beyond this one, if this is not able to take the load, it is going to scale that application. So this is what is going to happen. So I have set this one. Now I'm going to set the HPA. So initially I don't have the HPA now, horizontal pod autoscaler. So I'm going to create this HPA now. So by using this command OC autoscale. So I'm going to say the minimum. So minimum number is I'm going to say minimum I'm going to have 3, and maximum number I'm going to say 15. And I'm going to say the CPU percentage. This is very important. The CPU percentage I'm going to say 50%. The load is going beyond the 50%. Do the automatic scaling. Then I'm going to say the deployment name. So I'm going to set this in the deployment as well. The deployment, minimum the deployment, I'm going to say test app. I'm going to set this auto scale. Now you see that horizontal pod autoscaler. So this is created. and I will go to the separate tab here. So here what I'll do is I just do a watch command, watch OC get pods, OC get HPA. So this is going to, now you can see that HPA is created a horizontal pod autoscaler, and this is now the target is unknown. It is actually calculating the load. It is fetching the value from the metrics, calculating the load of that pod. So after some time, you will see this will go to 0. So that means initially it will not have a load. Then we'll apply the pressure. We'll apply the load, and we'll see how the scaling is going to work. Since we have said minimum 3, now you can see always 3 applications are going to run. So since in the auto scaling thing we have said minimum 3, always whether the load is high or not, the minimum 3 will be running. When you pressure it, when you apply the pressure to the node or this thing, so it is going to increase the number of application. So it's still calculating. It takes some time. Now just this project. Oh, 1 second, just I'm deploying and now still it is calculating. So we have to wait till this becomes 0. So once it becomes 0, now it's ready. So then we can go and apply the load. So, okay, so we'll create for this application. So we'll create the route, because using that route we are going to do the load test. So we have already have the service. So using that service, I'm going to expose this service, and I'm going to create a route. So now I have a route, also get route. And using this route, I'm going to apply the load. So I'm going to do something called API call. I'm using OC curl -x. The API call method I'm going to use here, get. So then I use this URL. So this URL is specifically designed for testing load. You cannot use this one for other applications. This is specifically designed for this one. So I'll use this one. Then /API /load test /version v1. So here I'm going to do CPU /1. So I'm going to apply 1 course of CPU. The maximum limit of the CPU is 100 millicores. So I'm going to ask it for 1. So this is going to apply pressure on that node. The maximum you can see the limit is 100 millicores. It's a 0.1. I'm going to ask for 1, so which is going to increase that load. And before I execute this URL, see now it has seen that it has changed to 0. Now it has calculated. Now I will apply this load. Now the load is getting applied. So you have to wait sometimes. Now I can see this is only 3. So once the load is increased, once you see this percentage goes beyond the value, you will see the number of application increases. Automatically it will be scaling. And when the load comes down, then it will be back to the normal. So whatever the normal number of applications you are giving. So if the load is coming back, but it takes some time, not be immediately, it will not reduce the load. So once the load is reducing beyond the 50%, you will see that it comes back to the normal load. Like normally it is running 3, it will come back to that. So we should wait for that percentage to increase. execute this again. Now you can see the increase in percentage. Also you can see now automatically it is increasing the number of pods. Previously we were seeing only 3. Now you can see now it is 6. Now it is also increasing. Now it is creating additional pods to meet the demand. So the demand is more, but here it is not a logical demand. Like it is not like I'm just demanding it, because even though the application can only do 100 millicores, so just to do some pressure to just to give some load, I'm using it. So depending in the real time, it's going to depend on the application nature. Now you can see it is automatically scaling. So depend between these values. So you can see now it has scaled to the maximum value. So minimum I've given here 3. The maximum is 15. So it is scaling beyond this. After this, it won't scale beyond this. Even the load is more, it is not going to scale beyond this. So that we are constraining. So we are not going to limit it. We are going to limit it to the constraint, so that it's not going to scale forever. So after some time, so you can observe that this will come back. So once the load is reduced here, so still the load is more. So once the load is under this 50%, then you'll see that the normal like normal number of pods will be running. It will reduce and only 3 pods will be running. So if it is the load is beyond below that value. Okay, so with that we complete the last section of the chapter, which is scaling. So following that also you have a lab. Okay, so we have 2 labs, so you can finish this lab. So there's a lab on this one, which is on page number 201, which is about the limiting resource usage. Then there is a lab about scaling. Scaling lab will be very easy. So the same which I've did it here. So same thing we are going to do then on the lab. So you're going to apply the load and see that once the load is beyond the required percentage, it's going to automatically scale. And as of now, you have to remember that only one criteria we have. Only have CPU criteria to examine, and that is the decision criteria, which is going to decide whether it should automatically scale or not. So we don't have no criteria apart from that. Maybe in future they may introduce some other criteria also, depending on the application memory or something. They can introduce other criteria. But as of now, we have only one criteria, which is very crucial for an application, which is CPU utilization. Okay, so you can finish these 2 labs and we can resume back. We can go for the lunch as well. Already we are late. So we'll resume back. So take your lunch and finish these 2 labs. So we'll be resuming back by 3:15 we'll resume. So I'm giving time for to do the lab also. So we'll resume between 3:15. So if you're completed by 3:15, we can start by that, or we can extend up to 3:30. If you're not able to do it, we will extend up to 3:30. So we'll resume between this time. So if you're finishing the lab by 3:15, fine. Otherwise, we'll start by 3:30. So with that, we complete the 6th chapter. Before proceeding to the upcoming chapters 7th and 8th, I'll come back to the 3rd chapter, because 3rd chapter is pending. As I told you, I'll be covering this later on. Technically, we have covered the core concepts. So about the storage, about the security, about the networking, about the scheduling. These are the core technical concepts which is required, which is you need out of this course. You need to know out of this course. So technically we have covered all this stuff. So now we'll cover about the product based thing. So many Red Hat products, we have the role based access control. So we'll see how to paid users, using the users, how to manage the roles and all these things. Once we are covering this, then we'll go and the 7th chapter is very small, just one section we do have in the 7th chapter. It's about how you make the cluster update process. And the 8th chapter is about web console. So how we are going to do the things which we have learned in the previous chapters, how we are going to do that thing on the web console. Web console, it will be very easy. It will be very easy to work when you compare to the command line, because you will see all the things in on one place, so that it's easy to go and get that things. Rather than the command line, you have to remember the commands and you have to remember the formats and all these things. But in the web console, it will be like a cakewalk, so you will easily able to use it. So we'll see that the last one. We'll see we'll cover the third chapter, then we'll go to the 8th, then finally we'll cover the 7th chapter. And also one more section is pending. So on the first chapter, so this is about the features. So we'll discuss, this will be the concluding section of our course. And one more thing, I will so there is a course survey. You can take up the survey now if you find time. Please take up this survey and complete this, because this link will be expiring by 5:30. So I'm going to put that link over here. This is a course survey link. Please take time to finish this also. The survey link, just it's about just provide your informations. Just give a rating for the curriculum, instructor, learning environment, overall rating. So how you are going to rate this course. And if you want to share any personal comments or any comments regarding the course, you can do that over here. And this additional questions is not required. So do up to this, fill up to this. If the additional question, if you want, you can take up additional questions. But to submit this survey, this is not required. So no need to complete these things, additional questions and you and your company details. So this is not required. So if you just complete up to this, it's fine. So complete up to this one, and then you can, this survey link will, the submit survey will be enabled once you complete up to that, then you can submit this. So please take